Hello. This is Lab 4. Welcome. Today we're going to be discussing Introduction to Research. Fun, fun. This one's going to be a lot different from your other lab manuals that you're going to have to do because it's not technically like the same structure. So you're not going to go through, watch a video, write down the results or anything like that, and then write a discussion about it. So this one, I'll talk about it a little bit later at the end, but this one is heads up going to be different, but very, very important. So introduction to research. I feel like uh, as a person getting a higher education, it's super important to understand at least like the basics of research and understand how to read an article. So we're gonna be talking about this today, and we're going to I'll tell you like how to read the article, what are good articles, what are bad articles. We'll go through all that stuff. So we're going to start off with research design. We're going to get into different articles, what peer review is, the structure of a scientific paper, scientific dishonesty, and I'll give you some resources that you can look at, like journals and things like that uh, for your project, essentially. And then I'll talk about presentation, how to do presentations, like your instructions for this specifically. I'll talk about the rubric, and then I'll talk specifically about tips on how to deliver a good presentation. You probably can't see this because I think that my face is covering John right here, but we have another John Cena gif right here up in the top corner. So important slides are marked with this, things that you should probably know. So research design, there's a couple of different designs that we're going to talk about. So qualitative and quantitative. Qualitative, think quality. So it's a descriptive type of research. You're not getting you're not doing any kind of experiment. These are going to be like your just observational studies. These are going to be your interviews, things like that. While quantitative is going to be more numerical, usually within a lab, and it's going to have generally a larger sample size, but it honestly just depends. I've found that a lot of qualitative studies have a pretty big sample size, while quantitative studies can have a pretty small sample size because of the in-depth modification or in-depth like experimental part of it. So you could have like only 30 people or something like that in a quantitative. These are going to be your experimental studies, so implementing a change. It's going to be your surveys, questionnaires, things like that. Different types of scientific articles. So when you're going through like Google Scholar or PubMed or anything like that, sometimes like just by looking at like the name of the article, it's kind of hard to decipher whether or not it's going to be one of these types of articles. But as you read more articles, you can kind of like figure out just by looking at the title, like, oh, that's probably like a review or like something like that. So we're going to talk about three. We're going to talk about primary, source, secondary, and special. Primary is firsthand research. So the people who wrote the article are the ones who did the research. So they collected the data. This is like going to be your original research articles, your case studies, things like that. While secondary sources are basically an article that pulls a bunch of primary sources together and talks about that certain topic. like systematic reviews, meta-analysis, like regular reviews. Meta-analyses are slightly different in the sense where they take the data specifically from those like primary sources, from those original research articles, and they analyze that data. So they put that extra step into it. So they have statistics, and they collect like data. They collect data, but they collect it from research that has already been done. And then special articles are like letters to the editor, editorials, like things like that. So something that isn't a review, but isn't like, doesn't have any primary research, doesn't have any data associated with it. So it's just like an expert discussing like an article, or like having their quarrels with an article, being like, this article didn't do this properly. So it's usually something like that. Peer review. So peer review is super important. Basically, it's like a standardization of like a level of expectation, or like a making sure that whatever research is being done or is like being written is up to a certain standard. So peer review is what it sounds like. A bunch of experts, your peers, or the peers of whoever's doing the research, are given the article that is submitted to the journal. They review the article, they give it the yay or nay, and then if they give it the yay, the authors can go on, publish the article. But if they give it the nay, they'll usually go back, edit it something, or if there's something egregious with the article, then the article just won't be published. And then non-peer reviewed articles are like newspapers, magazines, ads, things like that, things that like aren't reviewed by experts, essentially. And peer review, you'll usually just find that in a journal, while non-peer review sources, you can find it just anywhere on the internet. Okay, so what kind of supports peer review in making it like a good study? These are two different terms that are like super important to know: validity and reliability. Validity is the test, is that the measures of the test like does what it's supposed to do. So a test measures a certain thing that it's supposed to test. Like for example, the skin fold calipers, the ones that we like did in, what was it, lab 2, those measure body fat percentage using calculations and stuff. But if you're using skin fold calipers to, like, I don't know, say measure mass of a muscle or something like that, I don't know, that's not what they're designed to do. So that test would not be valid because it won't measure something like that. Like it only measures like your fat, your subcutaneous fat. It won't measure like muscle mass or whatever. Well, reliability is like the consistency or accuracy of it. So skin folds, if someone doesn't know how to do a skin fold, they're not going to be very reliable. But if a person who has done skin folds, like has a lot of experience doing those skin folds, that's going to be more reliable, because they can have very consistent results and can produce very like accurate data. Okay, so now we're going to talk about the structure of a research paper. We're going to be talking specifically about primary research, not secondary research or anything like that. So primary research articles will always have like a certain number of things. They'll always have a title, an abstract, introduction or background, method section, results section, discussion section. And sometimes they'll have a conclusion, but generally they just leave it at discussion. So they'll have the title in the beginning. Makes sense. And they'll also usually have like the name of the article or the name of the journal right here, the date, the issue, I forgot what the other term is, the issue, page numbers, things like that. And then they'll have the DOI. The DOI helps you find it online. And then they'll have an abstract right underneath the title, and that's this right here. So the abstract consists of a very brief summary of the entire article. So a summary of the introduction, the methods, the results, and discussion. And it's usually all in this order. So they'll start with the background, the introduction, and then they'll go through methods, results, conclusions. And sometimes they'll have like the purpose of the study sectioned off. This like article did really well and defined each section. Oh no, I'm frozen. I am unfrozen. I don't know if that will affect the recording or not. So hopefully, I don't know. We'll just roll with it. I don't want to restart. Okay, anyway, what was I saying? Yeah, so this article did a really good job at like defining each thing within the abstract. A lot of articles do not do that, so don't expect it for every single article that you read. But yeah, this one had a nice defined section for each one. Okay, then after that, the introduction or background information starts the article essentially. So the background information tells you a little bit about what the topic is and how it's relevant and what's important about the topic and current research about the topic. And it'll also include like a statement of purpose. So a purpose statement usually at the end. And sometimes it'll contain a hypothesis. They don't always put the hypothesis in there, but yeah. Okay. Next up is the methods. So methods basically tells you how they conducted the study. So what their research design was, the subjects, so the number of people is usually indicated with the letter N. Sometimes it can be uppercase, sometimes it can be lowercase, just depends. General data, so how they like collect the data, inclusion, exclusion criteria, and experimental procedures. That's where like they collect how they collect the data. General data of the subjects is usually like age, sex, where they found these subjects, and like other different aspects of the subjects. After this is the results. So they talk about the raw data. They don't discuss what the data means in this point of the article, but they talk about what they found and whether or not the results are significant or important. So they use that using p-values and alpha levels. So p-values are basically the odds of the results being an error. So the odds of VO2 max was significantly higher in whatever PA than MA is. And basically the chance of this like finding being wrong is 1%. So there's a 1% chance of this being wrong. An alpha level, on the other hand, is the acceptable range of error. So in ex-phys research, it's usually 0.05. In medical research, they need to be a little bit more like specific, and because they can't have much room for error, like for any kind of pharmacological drug, like you don't want that to be wrong, you know, you don't want something like that that could affect your body that much be wrong. They have to make sure that the treatment works. And as a note, not all results have to be significant to be important research. So something can be non-significant, but can like point to further research being done to determine whether or not that is important or not. Or it could be non-significant and mean that whatever that was is like not really important, not important, but not really like a big I don't know. I'm trying to form English words in my brain, but it's not happening. But they don't have to be significant to be important. And significant is within the p-values and alpha levels. This is also something that can be included in the primary research articles. So they'll usually have things like these tables. The results section will have this paragraph section. They'll have tables, they'll have graphs, if they're good. Graphs are very, very helpful in results sections. So they help to like visualize what the results are. And after the results section, you'll have a discussion section. So this is where they interpret the data. So the results section is the raw data, but they don't talk about it. They don't say like, this means this. So this is where the discussion happens. So they take the raw data and they talk about how this relates to real life. And then they explain what the results mean. They talk about the experimental limitations, so their study limitations, and then they talk about applications to real world, as well as future research that can go like based off of the research that they conducted. Yeah, okay, so how do we determine good and bad articles? Good articles, quality articles, have a high number of citations, not their references, but who has cited that specific article. Now, a good article doesn't have to have like a bunch of citations, because what if an article was published in 2021, it hasn't had enough time to be cited, you know? So it could still be a good article, but just hasn't been cited yet. An impact factor of the journal, so the journal that it was included in, that it was published in, the impact factor of that is fairly important. If it's a high impact factor journal, that means it's probably really hard to get your paper submitted into that journal. So they go through a high level of scrutiny, and it has to be good research in order to be published in a journal that has a high impact factor. Data publication, so is this research relevant? So if you get an article from like 1959, maybe that research isn't as relevant as something that's in 2018 through 2019. Things could change, things like methods of collecting data, or like statistical analyses, or something could have changed, and that means the data could have changed. References, watch out for people who use self-citation. So if they put themselves in the reference, so if they reference one of their own work, then that's like kind of sketchy. And also has to be peer reviewed. The journal has to be peer reviewed. So a good way of looking that up is looking up the journal itself and seeing whether or not it says peer reviewed on its website. Scientific dishonesty. So this doesn't happen too often, but it still happens sometimes. So plagiarism, you guys know what that is, using someone else's work. But you might not know self-plagiarism. So this could happen like in school, like if you've already written a paper for another class or something like that, and then a different class that you're in basically has you do the same thing and you just resubmit your paper, or you copy and paste some of the paragraphs that you used in that paper and put it into your new paper for your new class. That's self-plagiarism and you can get in a lot of trouble for that. So don't do that. Um, Fabrication, falsification, this is like really sketchy and really bad, and you can lose your job for this and like basically lose your academic career for doing this. But this is basically changing, manipulating, creating data that doesn't exist, or like removing data that would maybe like uh, interfere with what you were looking for, the outcome that you were looking for. So this is a big no-no. Don't do that. Non-publication of data. So a lot of people don't think about this. So if you do like a study, and this usually happens with like studies that are backed by certain industries, if it doesn't have a favorable outcome for that industry, they might not publish it, which is dishonest, you know? Like if just because they find something that isn't supporting that industry doesn't mean they shouldn't publish it. That's something that like really should be out in the world. Um, could also be removing specific data points to make a data like fit a certain result that they want to do. Faulty data gathering. This is so bad. So not adhering to your inclusion exclusion criteria for your subjects. So being like, this subject didn't meet the BMI requirement, but you'll add them anyway, just because like you need more people. That's a no-no. Because you have to be strict with like your IRB and everything like that. You already submitted like inclusion exclusion criteria to your IRB, and they already approved it. And if you go against that, that like they did not approve you like putting that person into your study because they didn't meet your inclusion exclusion criteria. Using faulty equipment, so using equipment that doesn't work, that can really like mess up your data. Bad record keeping. If you make your records like a mess and you can't ever find anything, that's not good. Or like not training whoever's working with you on this study. Like if you don't train Joe Schmo to help you out with your study, they'll probably do something wrong. So yeah, these are not good. Okay, so these are some resources that you guys can use for your project for this lab. All of these journals are peer reviewed. All of these journals are very, very good journals, and they're very relevant to the class. And I think you guys could find something really interesting in any one of these journals. You don't have to use one of these journals that are up here right now. But these are just something that like will help you if you get stuck or if you don't know where to look or anything like that. So you could also use PubMed if you want to like go through a specific topic. Google Scholar, the library website, those are all very good. I like to look for something on PubMed, and then if it leads me to a site or a journal that I don't have access to, then I'll usually copy paste the title of that article into the CSULB library like search bar or whatever. And then sometimes if luck is on my side, the CSU library will have that like available, and you can just download that from a site that they give you, or you can even request it on BeachReach, but it depends. Sometimes you might not get like the article in time. Sometimes it takes a while for BeachReach to give you your article, so don't always depend on that if you're short on time. Be sure to use your filters and or and be sure to use your parentheses as well. use CSELB for your free articles, sometimes Google. Sometimes before I go to the CSELB library, I'll copy paste the title and put it into Google. And sometimes there'll be like a bunch of options and then you can click and go through those options, see if you can find something for free. Okay, so what are you guys gonna do? I want you guys to choose a primary source, so not a review, with an experimental design. Not not a review, not a systematic review, not a meta-analysis, with an experimental design. Don't want observational studies because they didn't implement a change onto anyone. If you have any questions or if you want me to look at an article before you start doing your project about it, just email me and I'll try to get back to you guys as quick as I can. Okay, create a PowerPoint for it, discuss the introduction, discuss the journal. So, okay, first just discuss the journal, if it's a good journal or not. At least say the title of the journal. Then discuss the introduction, the methods, the results, and discussion. Record your presentation and then submit the video either onto Dropbox or publish it on YouTube and then include the link in your Dropbox. Yeah, if you can't record the video due to like technology purposes, let me know and then we can schedule like an appointment to do your presentation. We'll schedule a meeting, so everything will be okay. This is not reflective. You guys have 12 points for this, so I don't know what the actual rubric is, but it'll be kind of like this. Presentation tips. So make sure it's interesting. I don't want to like watch a bunch of like monotone, like blah 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 blah. It'll be I'll fall asleep. I don't want to fall asleep. And I hope you guys are watching this on 2x speed because you know I'll be watching them on 2x speed too. Make sure that you're just a little bit entertaining or that you have some sort of movement in your voice. Anything. Stick to the main points, so don't go too deep into like specific topics. You'll lose your audience. So you'll go on a tangent about something that's specific about the article that doesn't really have to like do with the results of the article. Yeah, don't do that. Don't spend too much time on extraneous things. Focus on the research and not as much the background information. Provide enough background information so I know what's happening and what's going on, like what is being talked about, but don't like make it a whole like 2 minutes of background information. More pictures. Everyone loves pictures. It's better. It's nice. It's you don't want to see a bunch of words. Like even this is probably too many words. Pictures are your friend. They will help you a lot. Make sure that the font is large enough that you can read it, that the audience can read it. That's super important. It's not as like uh not as important now that we're doing like Zoom, but like for presentations in general, like if you're doing them in person, you want to make sure that your audience can read your text. I've definitely made that mistake before. And use your slides as like something to go off of. Don't read them like directly. Don't read every single word of your slides, but have them help you deliver the content, you know? I don't want to like see you guys just go to each slide and be like, keep your audience focused on you, not your slides. The way that you present is just as important as the information you're presenting. I want you guys to like use your slides, have them help you remember what topics you want to talk about and remember what points you want to talk about, but don't make them like your entire presentation. Otherwise, I could just read your presentation slides. So those are some tips for presenting. I know presenting is really hard, but the more you do it, the better you get at it. So your framework, I kind of already discussed this. I want you to do an overview. So overview of the whole article, talk about the journal that it was published in. I want you to go over the background very briefly. I want you to talk about the introduction. So basically, like what their research question is, what they're looking for. I want you to talk about the methods. I want you to talk about the results, the discussion or analysis of it, and then have your own conclusion and your own thoughts about what was found and how does it impact like the real world. Okay, next week this lab is due, like just a video of you guys talking about the article. If you have any questions or if you're having trouble with this, please let me know. Email me, I'll try to help you guys as much as possible. All right, I'll see you guys soon.